They just wanted you, I think, to expand that out with the properties that were on 339. Is that the right one?
I looked at the wrong problem.
Oh, you mean, do you know how to do that? Or is that not the right one?
I looked at 23.
Oh.
That's why. I was like, oh, dude.
Oh, did you want me to do 23? I mean,
You can.
Yes.
But
It don't matter.
okay.
We didn't have to do it, so I'm like,
Well, I'll do it. I don't think it's too bad. Log, I'm going to write it x plus 1 to the 1/2 if you will, instead of square root, or x squared plus 1. If they want me to expand that out, you know, if it's a log of a fraction, I can write it as what? Log of numerator minus log of denominator. The only other thing I could do to that is bring the 1/2 in front and I'm finished. Nothing else I could do according to the properties. So that would be expanded. That was 23. Any other questions on any of those? Like I said, you're not going to see a lot of those three sections. You are going to see some compound interest questions, and just like the ones we did and assigned, and you will see definition of log like this. I mean, this is a real simple one, but could you get that? Yes. 4 to the 1/2 power is 2. That means take the square root of it, doesn't it? You'll see a couple of those on your next quiz. So that's almost the extent of the log stuff. But it is good to know these properties for when we get into what we do today. So. Any other concerns before we start? All right, so what we really want to do in this chapter, to finish it up, is to learn how to take the derivatives of these exponentials and logs. Okay? If I gave you this, whoops. What do you think y prime or dy dx would be? What would be the derivative of that? That's what we have to learn today. All right? What you're going to find, and if you'd like to look at this in the book, they derive how they come up with the derivative of this using our old standby. You remember what it was? Definition of derivative. All right? F of x plus h minus f of x over h. They show you how they use that definition on this function to find what the derivative is. And you know what the derivative is? You're going to love it. Itself. How strange is that?
What?
The derivative of this function is itself.
Itself?
I like it, don't you?
Why is that?
Well,
What's this?
if I plug that into my f of x plus h minus f of x over h using this function and do a little algebraic trickery and reduce it, and find a few values as they approach infinity, or as h approaches 0, actually. Right? As h approaches 0, you find that it's itself. And they go through the whole explanation in the book of how to derive that using this definition. All we have to do is use that result. So here it is. If y is e to the x, the derivative of that function is itself. What if it's a more complex function, e to some f of x? Then you have to use chain rule that we already know. The derivative will be itself times the derivative of that exponent. Isn't that easy? All right? If it's just plain old e to the x, it's e to the x. If it's e to something else like e to the 2x squared plus 3, it'd be e to the 2x squared plus 3 times the derivative of 2x squared plus 3. Chain rule. Well, they don't give you many of these in the book, but what if the base is not an e? If the base is not an e, then the derivative is itself times the natural log of the base of that exponential. I'm going to give you probably a couple of these on a quiz and the test, but I would give you these rules because they don't really have any of these in the book anymore. For some reason, they just dropped them out. But you know, you might in calculus come upon a function that doesn't have an e base, it has an a base or some other number, and I would like you to be able to find the derivative of it. You might have to. If it's a more complex exponent, then it's itself times the derivative of that exponent times the natural log of the base. Excuse me. Okay, that's this whole section. Mostly these. You want to try a few to see how easy they are? This is page 365. Look at 4. What if f of x is e to the negative 2x? What would f prime of x be? Itself times the derivative of that negative 2x. And you might want to just write that negative 2e to the negative 2x. How great is that? Could you try 6? 6 gives you f of x is 2e to the x minus x squared. What would be the derivative of that function? What's the derivative of this first term? Itself. And you're done. That's it. We just got to remember everything we've done. Do you see that it would be similar in number 8, except you'd have to use product rule? U squared times e to the negative u. That's all you'd have to do. You want to try 10 just for old time's sake?
Hold on just a second.
Okay.
Those are so simple, but it's scary.
Yeah, sometimes it's like that, isn't it? It can't be this easy, can it? What do I have to use on that one? The what rule? Quotient rule. So f prime denominator times what? Which is minus numerator. What's derivative of denominator? Itself over what? Well, what is e to the x squared? E to the 2x power. You multiply those exponents, don't you? So I could write it as e to the x minus x e to the x over e to the 2x. And the book might want to simplify that a little bit. They might factor out an e to the x and leave it 1 minus x over e to the 2x. Could I cancel out one of those e to the x's? What would be left? Would that be right? If I left it like this and canceled out one of the e to the x's, it would just leave the other e to the x. This is correct, but this is simplified. And you know the book would always go for the simplified answer. How about if we got a little more interesting and did, what would you say about 22? F of x, 4 minus e to the negative 3x raised to the third power. What rule would I have to use to find f prime? Chain rule. So what's derivative of outer?
3 times 4 minus e raised to the negative 3x power squared.
Times derivative of inner.
Positive 3x.
If I write out that whole step, the derivative would be what? Negative e to the negative 3x times negative 3. Do you agree? What would be a good way to write this final answer? What would I put out front? Negative 9. Actually, negative times negative would be positive 9. 9 e to the negative 3x times 4 minus e to the x, e to the negative 3x squared. So if I put that whole product in front, I get that. And there would be a good final form for my answer. Chain rule. Derivative of outer times derivative of inner. Those aren't bad, are they? No? You would agree with me that 26 and 28 would probably be no fun, but they're just product rule and quotient rule, right? You just have to be careful. Lots of signs going on, lots of things going on. Could you find the second derivative of number 30? F of t is 3 e to the negative 2t minus 5 e to the negative 2. What's the first derivative? This term itself times what? Minus itself times what? Yes. So I'm going to have, if I make it look better, negative 6 e to the negative 2t. Then what? I'm not sure if they would try to factor something or just leave it like this. I think leaving it like that's fine. Sometimes they think if you factored out an e to the negative t, it would be easier to use, but that's debatable. What if you made a mistake factoring out e to the negative t? Then you're messed up. Okay.
I have a question.
Yes.
How would you factor out e to the negative t?
If I factored out e to the negative t, that would leave negative 6 e to the negative t plus 5. The book might write it like
Okay,
that.
so it is that easy.
Yes. Because if I redistribute, would I get that back?
Probably.
I hope so. Question?
I thought we were trying to find the second derivative. Is that still there?
Yeah. And in fact, if I have to find the second derivative, I would probably want to use this form and not this because I'd have to use product rule, right? I just guess I was talking too much and not thinking. They did say find the second derivative. So to find f double prime, let's just use this answer I put a box around and tell me. itself times what? Plus itself times what? And then my second derivative would be 12 e to the negative 2t. There you go. And I would be fine with that. Again, you could factor out an e to the negative t in that answer, but is it worth it?
No.
So,
Simple as that.
I'm good. I'm good with that. Now, in the book, what if they did do that and you thought, I missed it? But you would see that maybe if you distributed their answer, you would get what you had. So, they're the same. Could you do 34? We have the same old questions we've answered over and over, but now with these new functions. 34 says, finding the equation of the tangent line to the graph of y equals e to the negative x squared at 1 over e. Okay. Well, you know, to find the equation of the tangent line, the slope is going to be, the slope at that point is going to be the derivative, right, at that x value. Tell me what y prime is. Itself times what? Okay. And at x equal 1, what is y prime? If I put a 1 here and here, is that going to be e to the negative 1 times negative 2? Would that be negative 2 over e? You know, it's always weird how the book might put the answer. I don't know if they would give a decimal for that or leave it the exact value. This is what we could say, though. To write the equation of the tangent line at that point, y minus y1 equals m times x minus x1. That's not too ugly, is it? Remember, that's my slope, isn't it? Y minus 1 over e equals negative 2x over e plus 2 over e. And if I add 1 over e, that's not too bad, is it? What would be my equation? Negative 2 over ex plus 3 over e. Sort of a strange answer, but that would be exact. That's not rounding. That's leaving the e in there instead of doing a decimal approximation. So what did we do? To find the equation of the tangent line, I found the first derivative when x is 1. And that was the slope that I used to write that equation. Okay? Same old questions, just different types of functions. Let's see. I want to try 40. Find the inflection points for f of x equals 2 e to the negative x squared. How do I find inflection points? Yes, set the second derivative equal to 0. What's the first derivative going to be?
2e to the negative x squared power multiplied by
And so to make it easier for the next round, you want to say it's negative 4x e to the negative x squared. I'll put that in front. How about f double prime? What will I have to use now that I have an x and an e to the x? Product rule. So that'll be by product rule, first function times derivative of second plus what? Derivative of first, which is times what? Original second. Good. I get 8x squared. 8x squared e to the negative x squared minus 4 e to the negative x squared. What do I have to do to that? Yes. Well, if I factor out 4 e to the negative x squared, the GCF, 4 e to the negative x squared, what's left over? 2x squared minus 1. All right. You know that this factor outside cannot ever equal 0 because it's e to that power. And an exponential can never equal 0, can it? So I don't have to worry about what I circled, but the other factor could. 2x squared minus 1 is 0. 2x squared equals 1. 1 half. So what's x? Plus or minus square root of a half. Look at this. Isn't square root of a half 1 over square root of 2? How do you rationalize that?
2 over 2.
If I multiply by square root of 2 over itself, I get this. So there are my two possible inflection points, right? And what we could say is the inflection points would be square root of 2 over 2. And what if I put square root of 2 over 2 here? It would be 2 e to the negative 1 half, wouldn't it? If I square that, I get half. And then I would have negative square root of 2 over 2. 2 e to the negative 1. There are my two, what I think are the inflection points. Are you in agreement that this is about 0.707, if you were to look at it? And 2 over the square root of e, that's going to be 1 point something, right? This is what I would do if you're not sure of that. Let's look at our graph real quick. If I graph the original 2 e raised to the negative x squared zoom 6. I'm going to zoom in once. Zoom 2 in. Look at that. Well, look at this. Do you agree that it's concave up here, but then it switches to down somewhere? I bet I know where. Negative 0.707, 1 point whatever, positive 0.707. Those are my inflection points that we found, right? There they are. It changes from up to down, and from down to up at those points. So we feel pretty good about that, I think. Those 2 points. If you wanted decimals, it's like 0.707 and 1.2 something, I believe, and negative 0.707. But you saw it. saw where it switched. Those are the inflection points where it changes concavity. So
Did you do Zoom 6 on your calculus?
I started at Zoom 6, and then I zoomed in on that.
Okay.
Zoom 6 gave me that little blip,
Yeah. So I was like, wait a minute.
and then I did Zoom 2 enter, and that made it even better. That was nice, then. And I could see what I needed to see. Let's see. How about 44? You see we're doing the same old questions we've done over and over, but with these new functions. Find the absolute extrema of h of x equals e to the x squared minus 4 on this interval. Well, you know, to find the absolute extremes, we just need to find the first derivative, the critical numbers, right? And then test the criticals with those endpoints to see which is highest and which is lowest, right? Remember doing that on the last test? So h prime is what?
E raised to the x squared minus 4 power times 2x.
Okay. If I set that to 0, we already said that this cannot be 0, right? So what's my only 0? If that can't be 0, set that to 0. There it is. And if you wanted to, you could say, well, since that's my only critical number, and it is in that interval, I want to find h of negative 2, h of positive 2, and h of 0. Pick my highest and lowest. Well, you agree that h of negative 2 is 1, isn't it? Is that right? 4 minus 4 is 0. What's e to the 0? 1. 2 squared minus 4, e to the 0. And if I put 0 here, you get e to the negative 4, which is a very small fraction, right? Point zeros, whatever, if you want to tell me e to the negative 4.
0.018.
Say that again.
0.018.
Approximately. Good. So, my absolute max happens at 2 points. Negative 2, 1, 2, 1. What's my absolute min? When x is 0, e to the negative 4 or 0.018 approximately. And if you graphed it, you see what's going on. If you graph e to the x squared minus 4, e to the x squared minus 4. Whoops. Minus 4. If I leave it on that expanded window, look at it. Do you see that from negative 2 to 2, negative 2, 1, and 2, 1 are max in that interval? What's the minimum? 0.018? I could zoom in again, I guess. But what if I went to my table? Look at that. There's my minimum. And at 2, it's 1. At negative 2, if I put in negative 2, it's also 1. So there we go. This was my minimum. That was my max. You see, nothing else was higher, was it? In that interval. In that interval. From negative 2 to 2. I'm not looking at anything outside. So, look at that graph again. Minimum here, max here and there. That's what they asked for. Couple of word problems. Look at 52. Says, pharmaceutical theft has been rising rapidly in recent years. They believe that the value of stolen drugs in millions is approximated by this function. Stolen drugs. 20.5 e to the 0.74 t. This is good for between 1 and 3, and I think that those represent number of years since 2007. Okay. Find the rate of change of the value of stolen drugs at t equal 2 and interpret your result. Well, the rate of change is going to be what? Find the derivative. Can you tell me the derivative of that? Times okay. And if we go ahead, and I'm going to get my calculator. If I say 20.5 times 0.74, you get 15.17. Do you agree with that? Is that 20.5 times 0.74? They said find f prime of 2. Well, if I put that in my calculator, 15.17 e raised to the 0.74 x. Go to your table. What happens if you put in 2? You get that? If you plug 2 into your first derivative, that tells me, let's look at the way they worded this again.
Millions of dollars per year.
Say that again.
Millions of dollars per year.
Yes, 66.64 million. And what's it doing? The rate of change, this would be per year. It's increasing at the rate at $66.64 million per year. In that second year, which would be 2 years after 2007, 2009. In 2009, I guess you could say that. It's increasing.
Wouldn't that be 2008? It says from 2007 through 2009.
So when it would be
So-
2008, 2 years would be 2000.
Would that be the second year?
2008, 2009. If you go to 2010, it's not in the range. It's from 07.
I think the way they defined it, they said if 0 was 2007, this would be 2008 to 2010. Is that the way I'm reading it? Is anybody?
The way they
That's
say
what
it
I
is
thought.
from 07 to 09.
Oh,
They don't say from 07 to 2010.
huh.
That's
Well, I
what
guess
it's
if they define year 1 as 2007, that would be 2008, I guess. I see your point. Okay. I guess that is the way they defined it. So that would be years 1 through 3, 7, 2, 8, 2, 9. So, okay. Year 1 being 2007. Usually, yeah, okay. I'll take it. But increasing at 66.64 million per year in year 2. How about if I say that? Whatever year 2 is there. But I think you're right. I don't think I'll make you suffer through 54, but can we talk about it a second? 54 gives you another function, g of t, and it represents the rate of growth of the world population. You see what it is. It's an e function, right? Part A says what's the projected population growth rate in 2020, which is t equal 3, third decade, right? All you do is plug 3 into the original G. But look what it says in Part B. How fast will that growth rate change in 2020? What do I find? Rate of change, G prime. Find the first derivative and plug in 3. That's all you'd have to do. So plug 3 into the original G for A, and plug 3 into the first derivative of G for Part B. Let's see if that would work. I'm going to assign you similar ones to those from this section. See if you can do these. How about page 365? I'll say 1 through 29, every other odd. Then I'm going to skip around and say 33, 39, 43, 51, and 53. Okay? Those should be plenty of those. Just to give you an example, since I said there were none in the book, I want to see from our notes, what if I gave you y equals 5 to the x, and I said, what is the derivative? Can I write that down? Y equals 5 to the x. Can you tell me what y prime would be from this rule? What would it be?
5x times
Yes. 5 to the x times natural log of 5. If I give you the rule, could you write that down on a test or a quiz? There's none of those in the book, but I think you need to know that just in case you come across them. Do you see the other type? What if it's a to the u of x? What if I gave you this? What if I gave you y equals 7 to the 3x squared power? And I said, what is y prime? Look at this rule again. 7 to the 3x squared would be what?
7 to the 3x.
So let me write that down. 7 to the 3x squared
6x
times the derivative of the exponent times what? ln 7. See that? Itself, derivative of exponent times ln 7. And that would give it to you. Could you do that on the test if I give you the rule? There's none of those in the book. I don't know why they dropped them out. They used to always be in the book. And when I made these notes back in the olden days, I included those in my exponential derivative notes. So I think it's always good to, couldn't hurt you, could it? So, all right. Now, how about this? What if we said, how do you take the derivative of a log? Yeah, that's exactly how you come up with it. Can you tell me what the exponential is from this? What to what is what? What's the base here? The base is e to what? Equals what? That means the same thing, doesn't it? Just another way to write it? Okay. If I want to find y prime, could I take the derivative of both sides by implicit? Remember doing that? We've learned so much, haven't we? And we're using it. What's the derivative of the left? What's the derivative of e to y? Itself times the derivative of that exponent. What's the derivative of y? 1 what? What did we always tack on if it was a y derivative? Oh, okay. Itself times the derivative of y, which is 1 dy dx, isn't it? What's the derivative of plane of x? Solve for dy dx. What did we just say e to the y was equal to? Here's my derivative. If you have y equals natural log of x, the derivative is 1 over x. Isn't that crazy? That's almost as easy as itself, isn't it? For the e to the x function. Derivative of natural log is 1 over that argument. Go ahead and turn over to 377. Okay. There we go. Too far. There we go. If y is natural log of x, then y prime is 1 over x. What if this is not just x? What if it's a larger function of x? What do I do? 1 over that whole function times what? By chain rule, derivative of inner, right? Derivative of outer would be 1 over that, just like this, times the derivative of that inner function. Sometimes your book wants to say it u prime over u. I like it better like that because it shows you the 1 over x part. 1 over this times the derivative of this. That's chain rule. Derivative of outer times derivative of inner. Okay. Once again, if it's not a natural log, then it's a little special form of it. Remember our change of base formula I showed you last time? You wanted to do a log on your calculator? If you use this first form of it, if you have log base a instead of log base e, then the derivative is 1 over x times the natural log of a. In other words, what's the derivative of this? 1 over x. 1 over x ln. So if it's not a natural log, if it's just a log base 7 or log base 3, that's the way you do it. But once again, your book doesn't have these. This book doesn't, and I don't understand that. If it's a more involved function, it's the same thing, 1 over that function, ln a, times the derivative of the n. And I would give you those if I ask it on the test, since there are no practice in the book. Okay? And this is on D2L if you need it. But this is mainly what your book is dealing with, these two. So you want to practice some of those? On page 377, could you tell me what would go on in number 4? G of x is natural log of 2x plus 1. What would be G prime?
Over 2x plus 1.
1 over 2x plus 1 times derivative of inner. So would you write that as 2 over 2x plus 1? Slow. Okay. That's easy, isn't it? Natural log 1 over times the derivative of inner. You can do that. Do any of those in that column, from 2 down to 22, do any of those look bad to you? That you think, I don't think I could do that?
When it's got fractions, how to go about that?
Let's do, you want to do 14? Let's see. 14, f of x, natural log of x plus 1 over x minus 1. What is f prime going to be? First I say what? 1 over that. Well, what's 1 over a fraction? the reciprocal, times what? Derivative of the inner is going to be quotient rule, isn't it, unfortunately? So denominator times what? 1, derivative of numerator, minus numerator times what? Derivative of denominator over what? Okay. Well, x minus 1 over x plus 1. I think this is nice. What's this up here? What's x minus 1 minus x minus 1? Yes. Is there anything else I could cancel? One of those. So what's my answer? Can you leave it like that, or do you want to call it x squared minus 1? Okay. I'm not sure if they'll leave it factored or not, but either of these two ways is fine. Okay? Make sure that's a negative. Still doesn't look like it. How about 22? I'm going to write it as f of x. How would I write that before I even do anything? Good. Yeah, that's square root, isn't it? Now if I said find f prime, what rule would I use? Chain. Outer times inner, right? Give me outer. Times, what's the derivative of inner? 1 over x for this one, plus what? Yes. It's not pretty, but that's what it is, right? In fact, I could move this down as a radical, but would that help me a lot with this ugly factor out there? So you could leave it like that if you want. I would almost think it would be easier to plug it in that form than trying to move things around and distribute. Okay? That would be ugly. Do you see that we don't have to do 30, but in 30 you'd have to use product rule? Be very careful with it. How about 38? Can you find the second derivative? F of x equals ln x squared. How about the first derivative? What's f prime? All right. Outer times derivative of inner. I could write that 2 ln x over x if you want. Now, when we go to second derivative, what will I have to do? Quotient rule. Unfortunately, denominator times what? Numerator prime. What is numerator prime? 2 times 1 over x or 2 over x. I like that. Minus numerator times derivative of denominator. all over what? What happens here?
Yes, it's canceled.
So I have 2 minus 2 ln x over x squared. I could factor out a 2, but it won't help me to cancel anything. So I guess that's fine. Second derivative. Do you see how we've sort of put together everything we've learned now? You see these are the same old questions, but with different functions now? So does that make you feel more comfortable with this? That we know how to do this, it's just we haven't done it with logs or exponentials before. Okay. 41 and 42 are interesting. I don't think I'll ask you anything like that, but they say use logarithmic differentiation. If you take the natural log of both sides, you could use the properties of logs to make them simpler functions. You know, split them as a sum and then bring the power in front, like in that last section we did. But I'm not going to ask you to do that, so I wouldn't worry about that. We probably do want to do oh, could you do 52? That's a good one. ln xy minus y squared equals 5. Find dy dx by implicit. Wow. Well, what would you say the derivative of this is? One over xy times the derivative of xy. Uh-oh. What will I have to use for the derivative of xy, unfortunately? The what rule? Product rule. There's an x and a y, right? So I would have to say first times derivative of second plus what? Derivative of first times original second. Minus what? 2y what? dy dx, because I took a y derivative. Equals what? Yes. I think I will distribute. What happens if I multiply this times this?
xy by x.
The x is canceled. 1 over y dy dx plus what? 1 over x minus 2y dy dx equals what? What's the only term without a dy dx tacked on? So let's move it over. Once this is gone, I'm sorry if I want to save space here, but once that's gone, could you all factor out the dy dx on the left? What's left if I factor out the dy dx?
1 over y minus 2y equals
1 over y minus 2y.
close parentheses equals
Good. Yeah, once that's gone, factor out the dy dx to get it alone. What's my last step? So dy dx, negative 1 over x over 1 over y minus 2y. If you don't like the complex fraction, and the book might do this, I don't know if they would, they could multiply by xy over 1 over xy over 1. What would that look like? This would just leave
negative y over x minus 2y.
x minus, would that be 2xy squared?
Yeah.
That's a little better form, isn't it? I almost would say that's worth it to clear those internal fractions. Okay. That one wasn't too pretty, but you saw where we were going with it, right? Okay.
Negative y divided by x minus 2xy squared.
That was sort of small and bubble. Okay. What would I have to do? I won't make you, but in number 54, to find the equation of the tangent line, what would I have to do to y?
Find the first derivative.
First derivative, and plug in what to find the slope of the tangent line? Once I find the first derivative,
2.
I would plug in the x coordinate at that point, wouldn't I? Plug in 2. And you would have the slope. Then you could write your equation just like we did a few minutes ago. What would I have to do in 56? Determine the intervals where the function is increasing and decreasing. First derivative. Those critical numbers would split your x-axis into intervals, and you could test a number from each one into the first derivative to see if it's positive or negative. It's increasing or decreasing. All right. Why don't we do 58? No more, what would you do? Let's do it. 58. Let's see. Determine the intervals of concavity for f of x equals ln x over x. Intervals of concavity. Well, to find intervals of concavity, I have to find the what? Second derivative. First, let's find f prime. Oh, by what? Your favorite? Quotient. Denominator times what? Derivative of numerator minus numerator times derivative of denominator over what?
X squared.
What's that?
So minus 1 x over x squared.
So now what will I have to do?
On those.
Denominator times derivative of numerator. Negative 1 over x minus numerator times derivative of denominator over what? Okay. Help me simplify the numerator. Negative x. If I distribute that 2x and the negative, will that be minus 2x plus 2x ln x? Is that right? If I bring that up a little bit, negative 3x minus 2x ln x over x to the fourth. Could I go ahead and factor an x out and cancel it? Negative 3 minus 2 ln x over x to the fourth. Cancel one of the x's.
I have a question.
Uh-huh.
How did the 2x ln x change from that right there, no, from that right there at the bottom to up there, up at the top?
Did you combine those two? Were those like terms? Negative x plus negative 2x?
Well, it will be negative 3x, and then you have minus 2x ln x. That's what I was asking.
Good catch. Good catch. Thank you. So this would be plus there. All right? Good catch. Negative 3 plus 2 ln x over x cubed. What do I do to that if I want to find the intervals of concavity? Set that to 0, but you know if I set a fraction to 0, I'm just worried about the numerator. So negative 3 plus 2 ln x equals 0. 2 ln x equals 3. ln x equals 3 halves. How do you solve for x? What does that mean by definition? What's the base here? Isn't that base e? What does that mean? E to the...
3 halves.
Yes. E to the 3 halves equals x. So there is my possible inflection point. So for the intervals of concavity, I would say what? I would say, actually for this one, I can't take the log of a negative, can I? So I'm going to have to say 0 to e to the 3 halves and e to the 3 halves to infinity. Those would be my two intervals. Would you agree that maybe one, oh, let's see now. If I put 1 in there, I would get 0. What if I put 2? Actually, yeah. E to the 3 halves. I could put a 2 in there.
Yeah.
Would that mean it would be positive? If I put a 2 in here, concave up. And if I put maybe a 5 in here, is it still concave up? Oh, not in the original. In the second derivative. Excuse me. If I put 1 in here, it's negative, isn't it? 1 makes a 0 here. Negative 3 over 1, that would be negative. So excuse me. Plug it in the wrong thing. If I plug 1, f double prime of 1, it's negative. Concave down. If I plug, why don't we say 3?
E to the positive 3 halves is 4.48.
4.48. So I would have to say 5. Thank you. If I plug 5, which is in that interval, is it going to be positive? 2 times natural log of 5. Yeah, I think that would definitely be positive. Yep. Okay. Concave up. What if you weren't sure of your result? What could you always do to this? You want to graph it real quick? So if I graphed, was it ln x over x? Divided by x, assume 6. Okay. We said from e to the, was it e to the 3 halves? 0 e to the 3 halves, we said it would be concave down. It looks like that, doesn't it? Looks like it's concave down. And at e to the 3 halves, does it change? Let's go out further. What if I extended that? Third. Hard to tell, isn't it?
Extend the y's.
Yeah. Maybe, yeah. What if I said negative 2 to 2? I could see it better, couldn't I? Ah! Bingo. was concave down up to here, then it switches to up to. All right. You said e to the 3/2 was about 4 point.
It was 4.48.
Okay. So at about 5 is where it changes from down back to up. That's good. Intervals of concavity. Since you've been so patient today, I'll do your word problems in this section next time. And we might go on to 5, 6 and see how things go. Actually, 5, 6 is the last section in this unit. So I'm thinking what's going to happen is we'll finish our notes next time. I'll give you a review day since we had, 2 chapters? Actually, part of 4 and most of 5. And then we'll have our test week from Wednesday. Notes Wednesday, review Monday, test. I will give you another take-home quiz probably next Monday. Go over this newer stuff. The ones I want you to try so far are these. And you let me know if they give you trouble. Page 377. Oh, I'm going to show you one more thing before I go.
So take home quiz Monday and then the test next Wednesday?
You let me write that down. 1 through 41, every other odd. 51 through 57, odd. And then we'll do some more of those next time. We said notes Wednesday, review Monday, test 3 Wednesday week. Okay. This is what I want to say real quick just because it's a good thing to end with. Remember what we said about if this is not LN, if it's LOG, what would you say would be the derivative if I gave you this, just to have one written down? What if we said y equals the log base 5 of x? What is y prime according to this rule? If this is log base 5 of x, 1 over x ln what? Yeah. 1 over x ln 5 from that rule. What if I gave you y is equal to log base 3 of 2x squared plus 1? Look at this rule. 1 over what? 2x squared plus 1, natural log of, is it 3? I've already forgot. Yeah. Y prime, 1 over 2x squared plus 1 times natural log of 3 times the derivative of that inner. What would that be?
4.
And that would be upstairs, wouldn't it? See what that was? Look at it one more time. 1 over 2x squared plus 1 natural log of 3 times 4x in prime. Okay? Just so you have a couple of those written down, since they don't give you any in the book, I wanted to show you that. Got about 2 or 3 word problems from this section, then we can do our last section. Then try to review. Okay? Have a good one. Thank you.